Welcome to Learn in 30 Minutes with Shell. We have expert data professionals with us who can give you some, insights into how digital twin works and how we use it in different assets around the world to help us monitor, enable better, efficient working of those assets. Joining me are Ishani Thakur and Akshata Ramamurthy, along with Vinod Gadgi. Now, Ishani and Akshata are our data engineers who work with Digital Twin and different teams around the world. Vinod Gadgi is our CC lead who leads this capability in Shell to kind of, enable more and more digital twin usage in Shell. So before we move forward, something that we like to do in Shell is have a safety moment. Safety is a big focus for us. So let's take a quick look uh, yeah, for safety. Please change the slide. Hi, are you changing the slide? Yeah, okay. So wherever you are, at home, at work, in a cafe, be seated comfortably. Be sure that you know where to go should an emergency rise up. Hopefully, you won't have to handle a situation like this, but it's good to know your emergency exits and where you need to be should a situation come up. Have the volume of your headset such so that you are aware of things going on around you. If you are on the move, we always advise that you do not be on a call in Shell. Road safety is a big focus for us, and we always advocate that amongst all our employees. So with that, we'll take a quick look at our disclosure statement. So just a quick note to kind of bring to your attention that whatever we share in this presentation is, not Shell specific. We have kind of made the information so that it's not confidential. Please don't try and quote this image out of the information out of context because, it won't make sense and it might be misrepresented. So with that, I welcome Akshata and Ishani. Digital twin, as is a new technology. It's very exciting. We work with digital twin in our conventional assets. Now, as you know, Shell is moving to newer energy systems. We have renewable energies, renewable fuels, all of that are being worked. Our first flight has taken off on green energy, renewables fuel with KLM. So we are on a journey. Until then, the conventional assets continue to support the requirement and demands of energy today. So with that, I hand over the rails to Ishani and Akshata.
Thank you, Ruchita, for the introduction. I'm Ishani. I'll walk you guys through the digital journey of Shell. First is the agenda that we'll be covering in this slide pack. First would be the introduction. It will be a small demo of digital twin. I'll walk you through the business vision, benefits, and value driven out of digital twin. There'll be a simple use case of digital twin in Shell. Then the methodology that we are using to implement digital twin is called Be Clearer. There'll be an introduction about it, the background for Be Clearer, the stages and sources, and we have a simple workflow as well for Be Clearer. Akshata, can you please help me with the demo?
Remember Blockbuster? A video rental store in the 90s. In order to watch a movie, you had to visit the physical store during its operational hours, walk the aisles browsing for what you want, or get someone on staff to look into their secret database to see if they can find it for you. And when you rent it out, it's checked out to you and no one else can use it. But today, with Netflix, you can watch videos and movies at your convenience. You can browse all the content for yourself and bookmark it to watch later, and there's no dependency or limit on the number of users who can watch the content. Project engineers and maintenance planners today experience something similar to a blockbuster experience. They spend a lot of time on site looking for information needed to pull together maintenance plans and equipment care strategies. But what if there was something like Netflix for all the data and documents relating to their site? Welcome to Digital Twin, a one-stop shop for all your data and visualization needs. Preventative Maintenance Planner. Meet Mike, a preventative maintenance planner. Today, he spends much of his time looking for information needed to pull maintenance plans together. While some information is linked from SAP, other information is not, or it's in other systems he doesn't have access to. He also must walk the plant to measure clearances. When Digital Twin is deployed, Mike will be able to find all the documents and drawings related to a piece of equipment by searching on the tag number. In addition, he will be able to view the equipment and its location in a 3D model or laser scan, and even measure distances in that 3D image. Mike will be able to see where other work is planned by looking at the mapping of work orders on a plot plan, as well as look at a historical work order and reliability data from RCM without logging into another system. PEI engineer. Meet Emma, a member of the Pressure Equipment Integrity team. She spends a considerable amount of time in the field inspecting CML, condition monitoring locations, validating piping and equipment configuration for equipment care strategies. Today, she must perform this inspection, validation to ensure the information is correct, such that the repair or care strategy is appropriate, and that Mike, the preventative maintenance planner, has what he needs to perform his job by building the most optimized maintenance plan. Emma wants to easily access and have confidence in design information, condition histories, change histories, projects or management of change, without the hassle of needing to mine WIMS, SharePoint, AIM, SAP, etc., in addition to verifying in the field. She also wants to see the data accurately visualized on the 3D model or laser scan. To see both together would be extremely useful to help determine the right tools and access points for the required inspection. Digital Twin gives her the ability to navigate to an equipment tag and see all the documents, drawings and master data, as well as information from GSAP and WIMS. This will enable her to efficiently establish more effective equipment care strategies without exposure to field risks. In addition to seeing the flat drawings, she can see where equipment is placed in the plant or unit in relation to other equipment using the laser scan or 3D model for the unit. Digital Twin will help Mike and Emma not only save time, but perform their jobs accurately and efficiently, and to go home safely at the end of the day.
Thank you, Akshata. I hope everyone was able to understand a bit about digital twin from the video that we just played. Now
What a
we'll go
nice
into the next.
demo. Very nice.
Yeah, thank you. We'll go ahead into the details of digital twin. So first, we'll talk about the definition of digital twin. So what is exactly a digital twin? It's like a virtual representation of any physical element. And for what is, if we talk about what does digital twin mean for Shell, it's an opportunity for Shell to replicate its production sites and get the data unified into a single system so that the visualization is easier and more efficient. Plus, it enables more improved decision making because now the data is in one single source. So any decision that need to be taken by any of the field engineers would be easier and more impactful. Akshata, can you move on to the next slide? So let's see what was the need for digital twin in Shell. So as we know, like a production plant is a very huge place, so it has data coming from different sources. Some of the data is simply in some sheets, some of the data would be in some databases, some data that we see from the that we recall from the video is in SAP. So there is no single source of truth as of now in a production plant. So what digital twin does, it kind of collaborates all that data into one place, and it makes the life of the maintenance engineers and the frontline workers easy. So now with the help of digital twin, the frontline workers and the maintenance engineers can take an impactful decision because they see the data as is, they have a single source of truth. So that makes their daily job way more easier.
So this
uh,
could also perhaps be used in, for instance, in the railways, right? So I mean, if you know, and all the trains can talk to each other, then you can probably, know where there's a problem, fix the problem before it causes a delay on the train lines, and then fix, and so that you are kind of on time all the time for your passengers.
yeah,
Yes.
that would also be possible with the involvement of AI and machine learning.
Yeah. So things like that. That is, so our assets are in different parts of the world. So imagine that if they can't talk to each other, it becomes a problem. And if one asset has a problem and another asset could have a similar problem, there will be delays. So that's
Yeah,
why the railway analogy also helps to understand, how are we connected across different destinations? The railway tracks that are connecting, like yeah, for maintenance and stuff need digital twin. People can manage it better, and the trains will always be on time. So our delivery of energy is then always on time.
yeah, exactly. Next slide, please, Akshata. So if we talk about the benefits of digital twin, so this makes the process better, faster, and efficient. The making is also faster and better. So when we talk about digital twin, once everything is, we have a virtual environment for everything. The operation inside a production plant is also easier. Plus, because we are working on the real time data, the decisions that we make, they are more efficient because they are based on the actual insights, based on the actual data that is coming from the production plants. Plus fewer people are need to design, operate, and maintain the asset at the physical site. So one problem that we have at any production plant are many safety issues. So if we have a virtual environment of the whole landscape, the number of workforce that is physically required at the place would be less. So the number of safety incidents would be lowered. Plus, this also lowers the unplanned downtime because now we have the data available. So if any maintenance is required, we can get to know about it way beforehand. So unplanned downtime would also becomes less.
So
Next,
unplanned downtime, going back to the railway analogy again, guys, is like, yeah. So if unplanned downtime would be, yes, there's a fault, the train has to stop, it cannot move forward, and passengers are waiting on the station. One of the trains might have to be cancelled because of that unplanned downtime, because the downtime is what we mean by maintenance time. So the unplanned downtime for an asset also means that we are not able to provide that energy or that requirement to our clients or to our customers or to our energy, right, users. So that's what, so unplanned downtime is that you prevent unnecessary delays.
exactly. Next slide, please. So if we talk about the UI interface for digital twin, currently we have three UI interfaces: Asai Cloud, Aviva, and Consberg. So when we talk about Asai Cloud, this is the document management and document control system. So at a physical site, we have a lot of documents that are created. Example would be, so we have a pump which is used to drill out the oil at a production unit. So, if supposingly there's any maintenance activity which is to be carried out on that pump, so there's some kind of the people at the site think that this particular equipment needs some maintenance, there'll be a whole document which will be created for it. It'll have the unique identification number of the pump. That means like at a site, if we have 10 different pumps, each pump would have a unique identification number, like an Aadhaar. So when there's a maintenance for one of the pump, the document would have that number, the Aadhaar number, supposingly. Plus, it will have the information like what was the maintenance activity, what all steps were taken, and when did it get resolved. Everything, all that detail of all that document would be collected in the Asai cloud. So this is used to view, review, and consolidate the documents. Plus, this is also used by third parties, people who are outside Shell, to review the documents who do not have access to the internal storage of Shell. Then we have
Just like how
Aviva.
you would call a call center and you have an interaction with them to say, okay, I am lodging a complaint because I did not receive this delivery on time. Now, you as a client can see that as
Yeah.
well as the systems, and your complaint ID can then be generated, and then the internal people who are the bank or the Amazon delivery or whatever else can also then follow and track the complaint and see that it is closed. So it's similar to that.
Yeah. So the second UI that we have is Aviva. This is the enterprise data warehousing system. So this acts as a master tag register. So supposingly we have a production site. Every equipment in that site would have like a unique identification number associated to it. In the oil and gas industry, we call it a tag. This is like your Aadhaar number. So as every person has an Aadhaar number, each equipment in a site has a tag related to it, and this is like unique throughout. And this also contains the document to tag relationship. So as we discussed, the Asai cloud has the document. So we talked about a pump which required some maintenance. The document, physical document, would be collected in the Asai cloud, and the attribute or the information for that particular tag would be collected in Aviva. So the relationship between the two, Asai and Aviva, is also stored in your UI, that is Aviva. And plus, Aviva also has additional attributes associated to that particular pump. Supposingly you we talk about your laptop. Your laptop has a unique number added to it. Plus it has other information also, like which company's laptop is it? Is it HP? Is it Dell? All that information would
Which
also be stored.
processor, which, yes,
Exactly. All
yes.
that information is also stored in our Aviva system. So, and the third system that we have is called Consberg. This contains the 3D model, as was shown in the video. Like we have a 3D model of the whole plant or the asset. So Consberg is the UI which is used to access those 3D plans. If you click on any of the equipment in that 3D model, you will be able to see all the information, the documents attached to it, the attributes. So you can think of Consberg as your Google Earth. So if you want to see a place, any place, you go to Google Earth, you just type the name of the place, and you're able to get a 3D view of the whole place. Consberg
Or a
works in a
satellite
similar
view,
manner.
or yes,
Yeah,
and you can play around with the location, right? You can even get a street
exactly.
view to see to different angles. You can rotate, walk down the street. So it's similar to that, right?
Yeah, as from that you can also see, you can get information about a particular place. So if you see a satellite view or something, you want to go and see, you want to find the restaurant nearby. So you can go and you can click on any, and it'll give you all the description or the ratings at least for that particular place. Consberg works in a similar way, but in like for a particular production plant. Next slide, please.
Cool. And just to go back to that, Ishani, right? Like when you said in one of your slides that the site doesn't require too many people because and it avoids safety incidents. So on the one hand, people can think, oh, well, are we going or not? Giving enough people jobs, we have enough jobs because then we have data engineers and more data engineers needed to be able to create that data, manage that data, import that data, create those 3D models. So, the job profiles and the personas keep changing, but there's always people needed to manage the technology.
Exactly. It's just a smarter way of working than
Yes.
physically going and doing it. So this slide talks about an example of digital twin in practice. Uh, if we see the pump number here, P15109A, this is the unique identification number that we talked about earlier. This is like your Aadhaar number. For this particular pump at a site, we have provided this as the Aadhaar number. If we go from the left hand side, we have the 3D model here. So the 3D model is the Konsberg portal's screenshot. So in Konsberg portal, this is how this particular pump will look. And once you click on it, we have the basic information. So if you see, like we have the information: is this pump active currently? What is the description of this pump? Where is it located? What is the maintenance unit? Like where is it located in the whole environment in the production plant? Plus, we have some of the data sheets that we can see. So if we see pump seal data sheet, this is like one of the document that is associated with this pump. Plus, we have the drawing. If you see this PNID, this is like a drawing of the whole production plant. So we can see like where exactly in the production plant is this particular pump located. And plus we can of course we can do any kind of analytics based on the data that we have in our in Aviva, Asai, or Konsberg. So we can create dashboards. Here if you see in the bottom we have a dashboard. So we can create any kind of dashboard which would help to make decisions and to have insights on the actual data. Next slide, please. So now we'll go to the B-clearer process. Uh, B-clearer is a methodology that we are using to implement digital twin. So it has different stages to it. So we have collect, load, evolve, and assimilate and reuse. So this methodology, when we get data, we use this methodology. We ingest the data from the first stage, starting from collect. And when we go to the reuse stage, we have the final product that can be loaded into our destination. For Be Clearer, the destinations that we have are Aviva and Asai, the two UI portals that we already talked about. So if we go to the first stage, the collect stage, what we do here, so we supposingly we are getting data from any of your databases, be it Oracle or SQL or any spreadsheet for that example, and a simple Excel. We in the collect phase, we just have a one-on-one replication of that data. Like it's like we are taking data from one storage system, we are taking it to another storage system. We take both structured and unstructured data. In the load phase, we'll filter out the data that we require. And if the data is unstructured, we change it to a structured format. Then we third is the evolve phase. This is the phase where maximum manipulation on data is carried out. We have two phases here: in system and across system. As I already mentioned, like at a site, at an asset, we would have data coming from different sources. uh, in system takes data from a single source, and across system would be collect and load would be happening for different systems separately. Then it will go to in system, and in across system, data from all those different sources would be collected together. It will be converted into one common metadata and then move to the other stage. So in the evolve stage, in system, if we talk about, first thing that we do is we provide a unique identification to each data row. We provide a classification as well. Classification is nothing but grouping. So supposingly we have something, we have pumps, we have pipelines. Pipelines are like if you see normal pipelines that pipes that you see at your home, which is used to carry water from one place to another. We have similar pipelines in a production plant which is used to carry oil from one location to another. So all of them would be classified. So all the pipelines would be classified under a single class called pipeline. All the pumps would be classified under a single class called pump. Plus, we also add some meaningful concept and categories to data. So as I gave you an example of your laptop, so you have fields like, oh, who's the manufacturer of your laptop? Is it HP? Is it something else? What is the processor? All that information would also be added in your in system. Then in across system, we are just collecting data from different sources. We are again checking for the identity. So supposing we are checking that the data coming from different sources do not have similar identification, unique identification. If that's so, we'll try to resolve those duplicates. Then in the assimilate phase, we ingest the involved data into a common model. And then we go to the reuse phase. Here we create the mapping to the target schema. So as I told you, bclearer has two destinations, Aviva and Asai. So both these systems, both these UI, they accept data in a particular format. Like if we say particular headers, supposing the Aviva takes data, it has 10 data columns, and the column name should be definite, like their particular names. So we try to map the data coming from assimilate phase into the target schema for Aviva or for Asai. Can
So
you go?
Ishani, I think it's also good to kind of mention how they can apply this in their student life, right? I mean, you were talking about a process that you manage with a lot of licensed tools from different companies. Even Be Clearer is a, product of a company called Boro, I think.
Yeah.
So yes, but what's the problem solving? What are the different, so I think what's good to kind of take away from this is that yes, you first collect data. So how do you manage data? You collect it, you load it, ingest it, evolve, and then assimilate, and then how to kind of structure that data in the different formats so that it can be ingested in the different solution or the systems. And then even in the hackathons or when you are solving problems or coming up with your products, this is the kind of way you can structure your research data. You collect it, you try and figure out how to process it, and then feed it to the different systems where you are trying to work. Yeah.
E- Exactly. This is just a process. So this can be used anywhere. So of course, when you are working on data, you can follow these steps. It'll for sure when you go to your next stage. Supposing you're going from load to evolve, the data that you have would be clean. And plus, like in all, when you build the whole pipeline, it'll be easier for you to kind of see if you're going wrong at any of the steps. The number of faults that you have would be less compared to if you are just if you don't follow any process and you're just targeting on the destination. So as you see, like it's going through the different stages. At each stage, there is some manipulation that is happening on the data. From the first stage to the second stage, we are filtering out some of the data records. In the next stage, we are adding additional information on the data. That is the evolve stage. Then in the reuse stage, we are just making the schema ready for the consumption layer. So the consumption layer can be anything. It can be any database, be it SQL Server, or it can be Oracle, or it can also be an Excel output. Sorry, I cannot. Okay. Now we have next thing we have what is the bclearer process. So bclearer is actually the product of a company called Boro. So these steps have been created by that company, and we are just reusing that methodology to implement digital twin here. And this is an open technology methodology which can be used by anyone. You can also use it for any of your projects that you are creating in uh, while you are in college or in future. So if we see on the left hand side, we have the before stage of bclearer. Here data is scattered in different sources. We ingest this data into bclearer. We process it through each step. We create a common we create a common platform of data, and then it can be ingested again to any of the different sources. As I already explained, you can ingest it into the databases, you can ingest it in Excel, you can ingest it into any of your analytic tool, or like a visualization tool like Power BI or anything, to create a new visualization on top of that. Next, we have gates. Gates are nothing but there are rules which we have implemented at which we can implement at each stage to filter out data. So you can take an example. Supposingly, you're creating a project to see what is the vaccination status of the students in your class. So at the end, you want to add only the information of the students who are fully vaccinated. So any student which has single vaccination or is not vaccinated would be filtered out at any of the stages, at evolve or at load. So this is the example of gate. Now, for Be Clearer, we specifically are using technologies like Azure and Python. For storing the data, we are currently using Azure's Delta Lake. For writing the functions to manipulate the data, we are using Python. For issue management, we are using the database Microsoft SQL Server. For your projects, you can use any of the open source. For storing the data at the first place, you can use Excel. For the data at for destination, you can use any of the databases that are available. This was the whole Be Clear process that we had implemented at Shell. You can also use the different steps to create any of your project, taking a simple Excel sheet. Then you can process it through all the steps, and you can load the data into any of the open source database, or you can create a dashboard using on any of the open visualization tools. That was all that we had today. This is just a part of the digitization that is happening in Shell. I hope you were able to learn something new today and would be able to implement it in future. Thank you.
So, yeah, thank you, Ishani. Just kind of, as data engineers, what would you advise the students? How can, if they get an opportunity to work with digital twin, would you advise them that this is the technology of the future and will help them, do some fantastic work in the jobs that they find somewhere?
Yeah, surely. So, digital twin is the next thing that is coming up in market, and when we come to the tools and technologies, it uses the most niche tools and technologies that are available. So, it uses all cloud-based tools. It uses Azure's cloud. It uses Amazon cloud. It uses machine learning. It also has artificial intelligence involved in it. So once you get to work in digital twin, you will be able to work using all these tools and technologies.
Super. So, I mean, so students, I think, great insight into what kind of technologies you can train in and how you can, kind of aspire for digital twin or train in digital twin so that, it helps you land the dream jobs and dream careers in the future that you can make a difference with. Thank you all. Thank you, Ishani. Thank you, Akshata. And thank you, Vinod, for bringing us together. Yep. Hopefully, you found this tip helpful. Um, Take care.
Thank you.
Thank you.
Thank you all.